Hello everyone, and welcome to this new Greenleaf Vision tutorial. In this video, I want to show you all the important functions and features of the new Trees Volume 5 Maple Trees asset. First of all, we navigate to the directory Trees Volume 5, Meshes, Trees. There are 3 folders here: Complex Wind, Simple Wind, and Windless. The first 2 folders contain, as the name suggests, the wind versions of the maple trees. In our first example, we will use an already completed scene from an existing map and replace a static tree with a wind tree. In this case, it is the tree mesh type B, and we opt for the nanite mesh variant. We will go into the topic of nanite wind mesh in more detail later. So we select the mesh, right-click on the transform field and select Copy All Properties in Category. We can then remove the tree and will now replace it with the wind tree mesh. We open a folder Complex Wind and open a folder with the nanite version. Then we select all tree parts and drag them into our scene. Right-click on the transform field and select Paste All Properties in Category. Now our wind tree is in the intended position. We can now combine the individual tree parts by using the group function. This can be done by pressing the Ctrl and G keys or via the menu. This gives us better control over the complete tree object later. In a later section, I will explain why we use these individual tree parts. Now we repeat the process, only this time with the simple wind version of the tree. We go back to the nanite folder, select all the tree parts, drag them into the scene, and place them in the correct position. The advantage of the simple wind version is that it requires less GPU memory than the complex wind version. If this wind version is sufficient for your scene, you save a lot of GPU memory and also have better performance. The Wind Trees Maps folder also contains an example map with the name Demo Map, Mountain Tree, SW, with customized wind parameters of the global foliage actor. SW in this case stands for Simple Wind. Let us continue. As you have just seen, the wind can be controlled via the global foliage actor. Always drag the global foliage actor into your scene to operate the wind controls and the seasons options. Now let's take a closer look at the wind strength function. A value from 0 to 2.0 can be set for the wind strength. The default value is 1.7. If you are wondering about the overloaded GPU memory warning message that appears, more on this later. Ground vegetation such as grasses and small plants can be controlled separately. We use the wind strength P slider for this. This means that the wind for trees and grasses can be configured independently of each other. This is useful in certain situations and helps you to make more precise settings. The following example demonstrates the wind strength function better. As you can see, the wind strength changes dynamically. Let us now continue with the wind strength auto switch function. This function automatically switches back and forth between 2 predefined values. Set the value to 1.0 to activate the auto switch function. The 2 fields below determine the minimum and maximum wind strength values between which the system automatically switches back and forth. Each individual slider function of the global foliage actor can also be controlled directly in the sequencer without any problems. The auto switch function is also available as a separate function for plants and grasses. In addition, the wind strength can be adjusted manually for each individual tree. This offers additional flexibility in the setting options. In this example, we are manually changing the wind strength for tree type I in the complex wind version. As this is the strong breeze wind version, we navigate to the folder SB, which stands for strong breeze. We now type _all in the search field and open both material instances that are displayed. Now enter the word wind in the search field so that only the wind settings are displayed. Here you will find the option W strength max, among others. Now pay attention to the highlighted tree in the scene. The value has now been changed to 0.1. This means that a lower value has been set for the maximum wind strength. Always set the same value for the bark material. It is also possible to adjust the wind animation speed. This is currently set to manual by default for all maple trees. If you want to control the wind animation speed for the maple trees via the global foliage actor, uncheck the box Wind Animation Speed M, which stands for manual. The wind animation speed field above it is then hidden. We now repeat the same for the tree leaf material. We uncheck the box. Now the wind animation speed for tree type I can be controlled directly via the global foliage actor. Now we come to the wind animation speed random function. If the value is set to 1.0, all plants in the scene are assigned a different wind animation speed value. The appearance is thus characterized by a more varied wind variation. This function is also available separately for the wind trees. However, you should note that this function only has an effect if the trees are in your scene as an instance and not as a manually set static mesh. Otherwise, this function has no effect. In our next example, we want to change the leaf type for a single wind tree. To do this, we open a leaf mesh of the desired tree type, then navigate to the leaf material directory and enter _all in the search field. We open the displayed material instance. We navigate directly to the required material instance via the parent field. The material instance has the name MI Maple Leaf Master CW All. We will now replace this predefined material instance with the leaf type P. And now we have defined a leaf type B for our tree. It is also possible to replace the bark texture. To do this, we navigate to the trunk material directory of the desired tree and open the trunk all material instance. In the global texture parameter value section, you can exchange all the necessary textures. If you want to replace the bark for all trees, navigate to the material instance MI Maple Bark Master CW. If you replace the texture in this material instance, it will be replaced for all complex wind maple trees. It is also possible to create your own material from scratch. To do this, you only need to copy the wind parameters into your own material. Also make sure that these are linked to the correct slots. Important here is world position offset and customized UV2 and 3. Replacing the texture also works for the static tree version. The static trees also include an opaque version. This means that no masked materials are used for these tree meshes. These are complete geometry meshes. This allows you to achieve an additional performance boost of up to 10 FPS more in your scene. Each wind tree is available in 2 different mesh variants. On the one hand, in a complete single tree mesh, and additionally in many individual tree parts, which are located in the nanite folder. There are several reasons for this. There is currently a limit to the use of nanite meshes in combination with complex wind animations. From a certain number of triangles, the wind meshes can no longer be converted as a whole into a nanite mesh. An additional nanite version is therefore available for all customers. On the one hand, this has the advantage that better performance can be achieved and, at the same time, is currently the only way to be able to use individual complex wind animations with nanite. The following tree types are available in a standalone complete nanite mesh with complex wind: C, D, F, H, J, M, N, and O. If you want to use the complex wind tree types A, B, E, G, I, K, L, and P with nanite, please use the individual tree parts which are located in the respective nanite folder. Always make sure that you drag all tree parts in the nanite folder into the scene. Otherwise, you will not get a complete mesh. An additional advantage of the individual tree parts is that you can omit selected leaf meshes. This allows you to additionally influence the leaf density of the tree. We now switch to the simple wind tree version. Here it is the same scenario. A complete mesh and the nanite folder with the individual tree parts. In the simple wind version, there are only 2 exceptions where nanite cannot be combined with the complete mesh. These are types E and K. For these 2 tree types, please also use the nanite version with the individual parts of the tree. With Unreal Engine 5.3, it is possible to define a shadow cache mode for meshes with world position offset. As shown in this scene, this new function has the advantage that we can assign different shadow cache types to selected trees. In this scene, the foremost tree has a different shadow cache type than the trees further away. This allows you to achieve better performance. The foremost tree mesh is currently selected. Now enter shadow cache in the search field. The shadow cache invalidation behavior function is displayed immediately. We can now select the shadow cache type. As you can see, the shadow cache option, rigid, has been set for the more distant trees. The shadow cache function is also available in the Foliage mode tool. Customize it according to your needs. We now come to the settings for the seasons. In the global foliage actor, you will find a fall amount slider under the season heading. The autumn slider can be used to change the leaf color. You can also use the autumn saturation to adjust the tone value. In the leaf settings section, you can hide the leaves using the Hide Leaves option. Set the value to 0 to hide the leaves and to 1 to show them again. Please note that this function does not work with the opaque mesh version. The brightness of the leaves can be adjusted using the Leaves Brightness slider. Set this as you wish. You can strongly influence your scene just by the brightness value of the leaves. There is also the snow function, which has an optical effect on the tree leaves, the bark, and the ground. These functions can be combined with each other as desired. All functions can of course also be applied to the wind vegetation. The leaf density slider currently only affects the trees from the assets Volume 1 to Volume 4. All other settings of the global foliage actor have the same effect on trees Volume 1 to Volume 4 assets. In the following example, I would like to show you how you can reopen a saved map in which the GPU VRAM memory has been heavily overloaded without Unreal Engine crashing. A scene with overloaded GPU memory can normally still be rendered with the sequencer without any problems. In the following example, we were able to render our scene via the sequencer despite the heavily overloaded GPU memory. Let's assume that your GPU memory is now overloaded due to the use of many different complex wind trees in your scene. You can still save your map, but you will no longer be able to open it afterwards. This is because Unreal Engine is not able to open a map with heavily overloaded GPU memory. The software will crash due to a GPU driver crash. In the following example, you will learn how to avoid this crash problem. This is enormously helpful as it allows you to create a scene with many different complex wind trees despite an overloaded GPU memory. Another important note: this procedure has only been tested with the complex wind trees from Trees Volume 5 and is therefore not a general guide for users. Unfortunately, we cannot guarantee success for every user. We will now replace many static trees from this scene with the wind trees. We will use many different wind tree types with complex wind to intentionally overload the GPU memory. Let's start with the first static tree. We copy the transform data again. Then remove the selected tree and drag the nanite wind version of the same tree into the scene. And set it to the same position. We use the group function again to be able to move or hide the tree mesh as a whole later. We will now do this for all trees that are visually in our camera field of view. In this tutorial, we will now take a small leap in time and skip this lengthy process. all static trees in the camera field of view have already been replaced by the wind trees. Despite the warning message about overfilled GPU memory, we save the map under a desired name and close Unreal Engine. Now we navigate to the folder directory Trees Volume 5, Textures, Trees. Here we find, among other things, two folders that we are now interested in. The folder with the name Vector T and the folder Vector T Imposter. We will now rename the Vector T folder by placing an underline after the T. We rename the Imposter folder to Vector T. Now we open Unreal Engine again. We now open our map with the scene in which we have just replaced the static trees with the wind trees. Don't be surprised if the wind trees no longer move as usual and are sometimes in a strange position. This is quite normal. Let's move on. As you have noticed, we were able to open the map without a software crash. Now select all complex wind trees. In this example, the nanite version with the individual tree parts was used for all trees. This results in a total of 3,202 tree part meshes in this example. Now we copy the tree data by pressing Ctrl+C. Then we open an empty text file to be able to retrieve the Unreal Engine code with the copied data later. Now we remove all tree parts. We can see that there are now only the static trees in the background, which are hardly or not at all visible in our rendered scene due to the protruding complex wind trees. Now save your map under a new name. We close Unreal Engine and change back to the directory Trees Volume 5, Textures, Trees. Now rename both folders to their original names. Then open Unreal Engine again. Open the map you just saved. The next step is very important and crucial. You now add all the complex wind trees that you originally used to your scene. It is important that you drag them into the scene one after the other and not all at the same time. Yes, that is correct. You do not need to set the trees to a specific position. We will remove them straight away. A process only serves to slowly overload the GPU memory. This prevents the software from crashing. And again, we will make a small leap in time. As you can see in this example, the GPU memory has been exceeded by a whole 16 gigabytes. The warning message clearly shows this. Some textures are also no longer displayed correctly in the viewport as the memory is overloaded. Now remove all the wind trees that you have just dragged individually into your scene. Now switch back to your text file from which you can now copy the Unreal Engine code for all the wind trees you have placed and paste it into Unreal Engine by pressing Ctrl+V. The software will now import all wind trees to the correct position. With this procedure, you can reopen any map that you have saved with an overloaded GPU memory warning. This procedure is only necessary for complex wind trees, and of course only if there is not enough GPU memory available. As previously mentioned, we were able to successfully render our scene with the sequencer despite heavily overloaded GPU memory. This method will probably only work with the sequencer and not with the movie render queue. I hope this tutorial has helped you to better understand the functions. You are always welcome to visit us on our Discord server to ask further questions. Thank you and see you soon.